But there is another, more intricate line of reasoning that frequently leads people to conclude that theistic evolution is inconsistent with providential guidance of the relevant sort. These considerations turn on a claim about the importance of unguidedness, or undirectedness, or randomness, in standard approaches within evolutionary biology. The argument, in a nutshell, is as follows. The sources of variation, mutations, etc., that are crucial to the theory of evolution that is accepted and advocated in current biology are supposed to be unguided, or undirected, or random mutations. This, in turn, means that any view that proposes that these variations are guided, or directed, or non-random will be in serious disagreement with the major pillar of the modern evolutionary synthesis. Therefore, if theistic evolutionists wish to align themselves largely with the consensus approaches in biology on this major theoretical point, and given our characterization of mere theistic evolution, they must, then they have to reject the claim that God, or anything else, guides these variations. Because of the importance of variation in evolution, this would amount to a rejection of God's providential guidance over evolutionary history. Appeal to something like this argument appears in chapters by Meyer, Moreland, and West in the book Theistic Evolution, a Scientific, Philosophical, and Theological Critique. Meyer's usage will be illustrative. If the theistic evolutionist means to affirm the standard neo-Darwinian view of the natural selection/mutation mechanism as an undirected process, while simultaneously affirming that God is still causally responsible for the origin of new forms of life, then the theistic evolutionist implies that God somehow guided or directed an unguided and undirected process. Logically, no intelligent being, not even God, can direct an undirected process. As soon as he directs it, the undirected process would no longer be undirected. On the other hand, a proponent of theistic evolution may conceive of the natural selection/mutation mechanism as a directed process, with God perhaps directing specific mutations. This view represents a decidedly non-Darwinian conception of the evolutionary mechanism. To recap the argument, the standard biological approach counts variation as unguided, which means that any position that claims they are guided by God will be at odds with standard biology. Therefore, if theistic evolution is best understood as a position that aligns itself tightly to standard biological approaches, then it cannot affirm that God has guided evolutionary history. The reasoning appears to be unassailable. But appearances are deceiving, as there is a subtle but significant problem with the argument above. To see the problem, it's important to recognize that the argument only works if guide has roughly the same meaning in the theological claim as it does in the biological claim. In other words, the line of reasoning is sound only if Meyer and West and Moreland are right to think of divine providential guidance as roughly the same kind of guidance that is denied of mutations in mainstream biology. If instead guide means something significantly different across these contexts, then the argument fails. By analogy, I may claim without contradiction that there are currently no matches at the All England Club, and that there are currently many matches at the All England Club, so long as the references are to different kinds of matches. And this could very well be the case, as the club may feature no tennis matches at present, and yet house hundreds of matchbooks filled with their little incendiary devices. This analogy is an apt one in the present context, for it turns out that the sense in which the biologist uses the term guided is significantly different than the sense in which the theistic evolutionist would use the term to refer to God's providence, and a proper understanding of this difference reveals that there is no danger of contradiction of the sort alleged in SPTC. As a number of philosophers of science and religion have noted recently, the biological sense in which evolutionary processes are said to be unguided, or undirected, or random, is a highly technical one, a stipulative sense that is perfectly consistent with those same processes being guided, or directed, or non-random, in the more ordinary sense that is assumed in attributions of divine providence. Elliot Sober, Alan Plantinga, and Phil Dow have all provided clarifications of this subtle but significant point. Here, we will explain the difference by employing a version of Sober's approach. To begin, it's important to recognize that many of the central claims of evolutionary theory are probabilistic claims. That is, they are claims about the likelihood of various changes occurring over time. The likelihood of various mutations occurring, the likelihood that an organism with such and such traits will produce more viable offspring, etc. And crucially, the probabilistic claims that are central to evolutionary theory are relative rather than absolute. This is true of many kinds of probabilistic claims, not just those that are used in evolutionary biology. Such claims are relative in the same way as claims about distance are relative. Just as there is no absolute answer to a question like, how far is it to Wittenberg? The right response in Berlin will differ significantly from the right response in Frankfurt. So there are also no absolute answers to most questions about probabilities. The point is key to understanding the biologist's technical use of the terms guided and unguided, and so we think it's worth clarifying by way of a simple example. Consider the probabilities associated with coin tosses. If you are asked how likely it is that a normal coin will land heads when it is tossed, and you have been given no more information about the coin or the toss, the right response will be to put the probability at 50% or 0.5. But importantly, the probability of heads is only 0.5, given that you don't know anything more than that a normal coin is tossed. If you had been given more information relevant to the outcome, then the right response might have varied accordingly. For example, were you also told that the toss was generated by a device that resulted in heads outcomes in 800 of the last 1,000 tosses, then your response ought to be that the probability is closer to 0.8 than to 0.5. And in some extreme cases, if you had complete and precise knowledge of all the physical facts and the circumstances, the physical properties of the coin, the laws describing the operation of the tossing mechanisms, etc., then because normal coin tosses are often practically deterministic processes, you could predict with certainty whether the coin would land heads or not. In such a case, we can say that the probability that the coin will land heads, given all relevant physical facts, is 1.0, or 0 if the laws and conditions determine that the coin will land tails. This may seem surprising at first blush. How, after all, is it possible for one and the same outcome, a tossed coin landing heads, to have a probability of 0.5 and a probability of 1? Isn't that contradictory? It is not. And the reason is that these two probability assessments are made on the basis of different background information. The first assessment is made only on the basis of the information that a coin is tossed, while the second is based on information that a coin with these specific properties is tossed under these specific conditions in a world with these specific laws. Both assessments are right, and there is no danger of contradiction. One might object that it is simply not true that both probability assessments are right. Rather, the assessment made on the basis of maximal information must be the right one, or anyway, it must be the more accurate of the two. But this is not true either. This is easy to see when we reflect on how we use coin tosses as a way of generating random outcomes, as when we determine who will receive the first kickoff in a football game. As above, in many conditions the probability that the pregame coin will land heads is either 1.0 or 0, given all the relevant facts. But since we don't know all these facts, we will get a very predictively accurate theory if we assign a probability of 0.5 to heads on any given toss. And indeed, when we toss coins, they do come up heads about half the time. Given the knowledge we actually have about coin tosses, a theory that treats the outcomes of tosses as random, as being equally likely to result in heads or tails, gives us accurate predictions, despite the fact that in many conditions, we would correctly assign a probability of 1.0 or 0 to each toss if our knowledge of the facts in each case were perfect. Something similar is true in evolutionary theory, and in a way that is directly relevant to judgments about whether or not evolutionary processes are guided. To see why, let's begin by considering the following question, which was at one time under serious discussion by biologists. Do mutations occur because they will benefit the organism, or do they occur independently of any potential benefit? While there was once some doubt about this, the matter is now largely settled. When it comes to mutations within our genes, there is no general connection between these genetic changes on the one hand and whether or not these changes will be beneficial on the other. To illustrate this point, let's imagine a simple case of a red cell placed in a green environment. In that environment, let's further imagine that the cell can undergo one of two kinds of point mutations. One kind will turn its color to green, while the other kind will turn its color to blue. Finally, let's imagine that if the cell undergoes a mutation that changes its color to green, it will be more likely to survive, perhaps because it blends into its environment. But if it undergoes a mutation that changes its color to blue, it will be less likely to survive. Given all this, and without knowledge of any other relevant facts, we might ask whether in any given case it is more likely that a beneficial green mutation occur rather than a non-beneficial blue mutation. As we noted just above, the answer to questions of this sort has largely been settled. In this scenario, and all other scenarios of this sort, the evidence is that beneficial and non-beneficial mutations are equally likely. The occurrence of a beneficial mutation, the green kind in our example, is not more probable or less probable than the occurrence of a harmful mutation. Importantly, this means that we can treat it as a random matter whether in any given case a mutation will be beneficial, in the same way that we can treat it as a random matter whether in any given case the outcome of a coin toss will be heads. In each case, treating the phenomenon as random gives you a predictively accurate theory over the long run. And it is in this sense that evolutionary biologists affirm that mutations and other aspects of evolution are random, where random is used interchangeably in biology with terms like undirected and unguided. Therefore, when biologists claim that science has shown us that mutations are unguided, the claim amounts to this. Given the facts that biologists take into account when making evolutionary predictions, those predictions are accurate if mutations are treated as random in the sense above, i.e., if they are treated as if the occurrence of a beneficial mutation is no more or less likely than a non-beneficial mutation. Mutatis mutandis for other aspects of evolution. And just as was true of the coin tosses, there may be other relevant factors that are not taken into account within evolutionary theory that change these probability assessments significantly. To illustrate, we can return to our example of the red cell in the green environment. If, in contrast to our original case, we were provided instead with much more information about this situation, say, complete and precise knowledge of all relevant physical facts, then, assuming that the relevant processes are practically deterministic, we can predict with certainty whether or not a beneficial green mutation would occur. Given this background knowledge, our probability assignment for a beneficial mutation would either be 1.0 or 0. Generalizing, we can say that in many cases, the probability that a beneficial green mutation will occur is either 1.0 or 0 given all the relevant facts. Even so, and again, similar to the coin example, since biologists don't know, and don't typically need to know, all these other facts, they will get a very predictively accurate theory if they assign a probability of 0.5 to the occurrence of a beneficial green mutation in any given case. And so a theory that treats mutations as random, where in this context that means being equally likely to be beneficial or non-beneficial, gives scientists accurate predictions, despite the fact that they would correctly assign a value of 1.0 or 0 to the probability of a beneficial mutation in many cases if they took into account all relevant physical facts. But now it is a straightforward matter to show that one and the same mutation can be both random and completely determined by God. Or, to put the point in the terms that motivated our discussion, we can show fairly easily that an unguided mutation can be completely guided by God. Let's first illustrate how this might work by returning to our example of coin tosses. Imagine a referee who has a gambling addiction and bets on every football game that he officiates. In order to boost his winnings, this referee has learned how to toss coins to get just the outcome that will benefit the team on which he has bet. For example, if his preferred team calls heads, he makes the pre-game coin land heads, and if the team he has bet against calls heads, he tosses the coin so that it will land tails. Now, let's assume further that when captains pick heads or tails before the pre-game coin toss, they do so randomly. They pick heads half the time and tails half the time. Under these circumstances, a referee's coin tosses will, over time, yield roughly the same pattern as ordinary coin tosses, landing heads half the time and tails the other half. And this means that an approach that treats the outcomes of these tosses as random, i.e., as equally likely to land heads or tails, will be a very predictably accurate theory. For the distribution of the heads and tails outcomes in these games will match the distribution that is expected if the probability of a heads outcome, in any given case, based solely on the information that a normal coin is tossed, is 0.5. In this sense, then the outcomes of these tosses are correctly described as random. Even so, it is also true that the referee can guarantee the outcome that he desires on any specific toss, and he exercises this ability to determine exactly how the coin will land. In light of this, we could say that based on additional information, in particular, information about the referee's intentions for the toss, the probability of a heads outcome in any given case will either be 1.0 or 0. There is, therefore, a second sense in which the outcomes of the coin tosses are not random at all, because they are precision guided by the referee. It's even easier to see that random coin tosses can be divinely guided. Suppose that God determined, via his ordinary providence, the outcomes of the pre-game coin tosses for the last 10 Super Bowls. It is certainly true that the probability that the Super Bowl 44 toss would land heads was 1.0, given all relevant facts, now including not only the physical facts, but facts about God's actions as well. But because, let's assume, we lack knowledge of God's intentions for this toss, and the tosses to follow, as well as knowledge of all relevant physical facts in each case, the right probability to assign to a heads outcome in each of the 10 tosses was 0.5. In other words, even though God was determining the outcome in each case, the right approach for us was to treat it as a random matter, whether any given toss would land heads, as this approach made for a predictively accurate theory over the long run. And, to come to the key point, the same is true of the random or unguided mutations in evolutionary processes. Let's suppose that God determined exactly what kind of mutation, beneficial green or non-beneficial blue, would occur in 10 cells, one after the other, in the following order: green, 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 blue, 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 green, blue. Could he have done so through the exercise of his ordinary providence, in a way that nevertheless kept those mutations unguided in the biological sense? Given our explanation of what unguided means in biology, the answer is clearly yes, and for reasons that are similar to those given for the coin tosses. It is certainly true that the probability that the first mutation would be beneficial was 1.0, given all relevant facts, now including not only the physical facts, but facts about divine activity. But assuming that we lack knowledge of God's intentions for this mutation and those to follow, as well as knowledge of all relevant physical facts in each case, the right probability to assign to a beneficial mutation in each of the 10 cases would have been 0.5. In other words, even though in half the cases God determined that a beneficial mutation would occur, the right approach for us would be to treat all 10 of the mutations as unguided, as though beneficial mutations were no more or less likely than non-beneficial mutations, as this approach would have given us accurate predictions over the long run. What is true of this one simple case can be generalized to all mutations, and indeed to all aspects of evolution, if we take into account the kinds of facts and principles that are standardly used in evolutionary biology. We can accurately predict that evolution is unguided, in the sense that mutations do not occur because they carry some benefit for the organism. But this is perfectly compatible with the outcomes of evolutionary processes being guided in another, entirely legitimate sense by divinely caused factors that evolutionary biologists are not taking into account. More simply, the standard biological claim that evolutionary processes are unguided is compatible with the claim that God guides them, because guide has different meanings across the first and second instances. The combination of these two claims, properly clarified, means only this. A. According to the best accounts within evolutionary biology, beneficial mutations are no more or less likely to occur than non-beneficial mutations. And B. God providentially governs evolutionary processes to include bringing about certain mutations to achieve his purposes. Put thus, it is clear that the theistic evolutionist can endorse consensus views in the sciences concerning the relevant biological facts, while also endorsing the claim that God guides evolution through his ordinary providence.